Hello everyone, Cousin here, and in this video, I'm gonna be solving Wordle number 1264 and New York Times Hard Sudoku for December 4th, 2024. So let's get this video started with Wordle number 1264. I'm gonna start with the word blown. Okay, all of the 5 letters are grey, so let's guess another word with 5 new letters. For example, stare. Let's try that. Got the T and R yellow, so these 2 letters go somewhere else in this word. This word could start with TR, something like Shrek, and let's actually try that, because why not? Okay, still have not placed the T. I placed the R as the second letter, and I also know that C is another letter which goes somewhere else in this word. So it could be CR double consonant. CR, and then surely it would have to be a vowel, CRU, or it could be a Y. Because, of course, you know that A, E, I, O, and U are vowels, but we also have semi-vowels, which are consonants but can act like a vowel. I don't know if I'm explaining that um, accurately, but Y is known as a semi-vowel, so it could be a Y. There are some words um, where there are no vowels, but there is a Y. For example, sky or dry, or a lot of words that actually have Y, but no A, E, I, O, U. So Y is also an option, but T still has to go somewhere. So I'm thinking T goes last. Or it could be TH, but I don't think these are words. So T should go last. It won't be CRT, of course, because you can't pronounce that. CR something something T. Um, and I think the Wordle answer is going to be crypt, because that's the only word that I see. Before the T, well, there's only one vowel, right? Because, yeah, there should be only one vowel, and in this case, I'm only thinking of crypt, so let's go with that. And crypt is today's Wordle answer. Alright, got it in 4 tries. So yeah, I didn't really use any elimination strategies or anything like that. I just made my guesses based on the previous clues, and basically, after the third guess, I could place C, R, and T. Well, I guessed those positions correctly, and the only vowels or semi-vowels remaining were U or Y. So after that, I guessed today's Wordle answer successfully, crypt, in 4 tries. So yeah, I'll take that. An alright performance. So yeah, got today's Wordle answer, crypt, in 4 tries. This is Wordle number 1264. After I'm done with this, let's move on to New York Times Sudoku. Again, today is December 4th, 2024. Let's start the hard difficulty Sudoku for today. I see that these ones force the digit 1 into this cell in block 2. This one points down, and this one points left. So in block 5, the digit 1 is forced into row 6, and then once here points left, and this cell sees another 1. So in block 4, the digit 1 is forced into one of these 2 cells. We also have these ones pointing down. Okay, now let's move on to the 2s. This 2 points left, to force the digit 2 into this cell in block 2, and then these 2s points left. This cell sees another 2. 3s. These 3s points right. This 3 points down, and this 3 points right. So in block 5, the digit 3 is forced into row 6, and then these 3s points right. You might have noticed the 1-3 pair in block 5. As you can see, these 1s and 3s force both 1 and 3 into these 2 cells only. So in order to fit both 1 and 3 into block 5, I have to make these two cells reserved for 1 and 3, because once again, both 1 and 3 can only go into these two cells. So this 1-3 pair eliminates all other digits from these two cells, because once again, they are reserved for 1 and 3. So, now, because of these 9s, I can force the digit 9 into this cell after eliminating 9 from the 1-3 pair. So 9 is forced into this cell in block 5. These 9s point right to force the digit 9 into this cell in block 9, and then these 9s force the digit 9 into one of these two cells in block 6. These 9s point left, and this cell sees another 9. So in block 1, the digit 9 is forced into this cell and into one of these two cells in block 4. Okay, now, this 6 points right, and 6, of course, cannot go into the 1-3 pair. So in block 5, the digit 6 is forced into column 5, and then these 6s point down, and this cell sees another 6. Alright, the missing digits of block 2 are 7 and 8. This 7-8 pair makes the other 3 open cells in row 3 a 4-5-6 triple, because 4, 5, and 6 are the other missing digits of row 3. This cell sees a 6. Okay, another thing that I noticed by the placement of these 3s is that they form a mini X-wing. So the concept is that no matter if 3 goes like this or the other way, these open cells down here that are in columns 8 and 9 will see these 3s up here. So in block 9, after eliminating 3 from these open cells, which are in columns 8 and 9, I can force the digit 3 into column 7 in block 9. So 7 is, so 3 is forced into one of these two cells. Because we've already got 3 in columns 8 and 9, no matter if 3 goes like this or the other way. These open cells down here cannot contain a 3. So that's why I can eliminate 3 from these cells and place 3 in one of these two cells over here. Another way to explain this is that in column 7, 3 is a missing digit. These open cells see another 3. So in column 7, the digit 3 is forced into one of these two cells. And because in this column, 3 is guaranteed into one of these two cells, no other open cells in block 9 can contain a 3, because 3 must appear in one of these two cells. Even if it's for that column, it's a must that 3 goes into one of these two cells. So no other open cells in block 9 can contain a 3. Okay, but I really can't place any digits immediately, so we'll just mark those down. Okay, this 2 points right, and this cell sees another 2. So in block 9, the digit 2 is forced into row 7, and then these 2s force the digit 2 into one of these two cells in block 8. These 5s point up, and this cell sees another 5. These 5s point down, and this cell sees another 5. Oh, but 5 must go into this cell. 2 reasons. Well, actually their concept is similar, but you can explain it in 2 different ways. First way is that this 5 points right to force the digit 5 into row 9 in block 9. So this cell now sees 5 from block 9. So this cell cannot contain a 5 because there's already 5 in row 9. So 5 is forced into this cell. because of the fact that in block 9, 5 is forced into row 9. The other way to prove it is that just by looking at row 8, these 3 cells see this 5, this cell sees 5, and this cell also sees another 5. But 5 still has to go somewhere in row 8 because it's still a missing digit. So in this row, the digit 5 is forced into this cell. So 2 ways to explain it. Of course, same result, so yeah. You get a 5 in this cell. After that, one of the 2 possibilities for 2 is removed, so I can immediately make the other cell a 2. You can double check it by seeing that these 2's force the digit 2 into this cell in block 8. Okay, in row 5, 2 and... Oh, okay. First of all, well, I should say that in row 5, 4 is a missing digit. These 2 cells see 4, and this cell also sees another 4. But I still have to put 4 somewhere in this row. So in row 5, the digit 4 is forced into this cell, as this is the only cell available for 4 in this row. And then 2 is also a missing digit. Now, after 4 occupied this cell, all other open cells see another 2. So in row 5, the digit 2 is forced into this cell, because this is the only cell available for 2 in this row, which leaves behind a 7-8 pair, but actually this cell sees an 8, so I can place the 7 and 8 this way to complete this row. Wow, okay, row 5 is done just like that. Okay, well, this 1-3 pair makes the other 2 open cells in block 5 a 6-7 pair, and notice how this 6-7 pair lines up in column 5. So this 6-7 pair makes the other 2 open cells in this column contain 4 and 8. This cell now sees an 8, so I can make this 7 and this an 8 to complete block 2. This cell is for 1 or 3 only for this column. This cell now sees a 4. So for row 3, 4, 5, and 6 are missing digits, and this cell indeed sees 4 and 6, so it must be a 5, also according to the markings I've done, leaving behind a 4-6 pair in this row. The 7 points up and the 7 points right. So in block 3, the digit 7 is forced into one of these 2 cells in column 9. So 7's here, and the 7 points down. You might have noticed that these 2 cells form a 3-7 pair. As you can see in block 9, I've marked both 3 and 7 into these 2 cells only. Or in other words, both 3 and 7 in block 9 can only go into these 2 cells. So in order to fit both 3 and 7 into block 9, I have to make these 2 cells reserved for 3 and 7. So this 3-7 pair eliminates all other digits from these 2 cells. So that means 2 can no longer go into this cell. I can force the digit 2 into this cell in block 9 after eliminating 2 from this cell. And then 2 in block 6 is forced into this cell. Another way to place this 2 is just by looking at column 7. 2, 3, and 7 are the missing digits of column 7, and this cell sees 3 and 7, so it must be a 2. Okay, the digit 5 in block 6 is forced into one of these 2 cells. We also have 6 as a missing digit. This 3-7 pair makes the other 3 open cells in block 9 a 1-5-8 triple. This cell sees 5, so it's 1-8, 1-5-8, and 5-8 because it sees 1. Okay, I see something. This cell... Okay, let's find out what digits this cell can contain. So this cell sees 1, 2, 3, and 4. It does not see 5, so it may contain a 5. This cell also sees 6, 7, and 9. but does not see 8, so it also may contain an 8. So the possible digits that go into this cell are 5 or 8. Now look at column 8. There are 3 open cells which only contain 3 certain digits. In this case, these 3 cells only contain 1, 5, and 8. And remember that in Sudoku, we cannot leave cells empty. So to avoid empty cells, I must keep 1, 5, and 8 in these 3 cells. Because if I were to put one of these digits elsewhere, let's say I put a 5 in this cell, then at least one of these cells would end up being empty, and that's no good. We cannot have empty cells in Sudoku, so in order to avoid empty cells, I must keep 1, 5, and 8 in these 3 cells, because once again, no other digits apart from 1, 5, and 8 can go into these 3 cells, so I must keep 1, 5, and 8 in these 3 cells. So I can say that this 158 triple eliminates 1s, 5s, and 8s from all other open cells in this column, meaning that 5 can no longer go into this cell, because it sees 5 involved in this triple. So after eliminating 5 from this cell, I can force the digit 5 into this cell in block 6. It also means that these 3 cells form a 369 triple. Hmm. Okay, well, I missed this, but all of these 5s force the digit 5 into this cell in block 1. Oh, and after I place this 5, 5 in this cell is eliminated. I can force the digit 5 into this cell in block 9. So these 2 cells are down to 1 and 8, and this cell sees 1, so I can place 8 and 1 this way. Um, okay, yeah, this cell now must be an 8, because I've just talked about the 158 triple. So I've placed the 1 and 5 here, so this cell must be an 8, because it's involved in the triple. Okay, and then the missing digits of row 1 are 4 and 7. I should also mark down 6 in this cell, because it's also a possibility. Okay, this cell now sees a 1 that I recently placed, so I can complete column 4 by placing 3 and 1 this way, which makes this a 3, because of the pair. Now, column 6 is missing 1, 6, and 7, which goes into the open cells. Something's wrong with this row. This cell now sees a 3. So I can make this 7 and this a 3 to complete this column. This cell now sees 1 and 7. So for column 6, I can make this a 6, leaving behind a 1, 7 pair. This cell is for 4 or 8 only for this row. This cell now sees an 8, so I can make this a 4 and this an 8, and this a 4 to complete this row. Row 9. The missing digits are 1, 6, and 7. This cell sees 1, so it's 6 or 7. 1, 6, 7. Okay, the digit 3 in block 7 is forced into this cell. Okay, the missing digits of row 8 are 1, 7, and 8. Okay, the digit 2 in block 4 is forced into one of these two cells. Okay, this cell now sees a 4 that I recently placed. So for row 1, I can place the 7 and 4 like this to complete this row, which makes this 6 and 4 this way to complete row 3. This cell now sees a 6, and for column 9, I can finish it by placing the 3 and 7 this way, which makes this a 3. 6, 9 pair left in column 8. Hold up.